Hi, hello friends, welcome to my YouTube channel. Now, based on the request from YouTube comments, I would like to start the power electronic lectures. So, in this lecture series, first I will start with the power semiconductors and what is power electronics and what are the applications of power electronics and switching properties. Now, friends, the origin for the power electronics is from our electrical power transmission systems. So, let's say electrical power transmission systems. So in the electrical power systems transmission we have generator, that is nothing but alternator. In a network analysis we can call it as a source, and here we have a load. In electrical terminology we can say it as a sink. So in order to transfer the power or energy from this generator to the load, we are using transmission lines. So this is a transmission line. So the power may be AC or DC, or load may be DC or AC, whatever it may be. So here we are going to perform switching operations here. So switching operations. So why we are going for switching operations? In order to control the power which is flowing from source to the load. Okay, so switching operations. So normally there are two types of switches: mechanical switches and electrical power semiconductor devices as switches. So mechanical switches perform very less operation and very less switching operations, and the electrical or power semiconductor switches or power semiconductor devices switches performs very switching operations such as MOSFET. So it may be around 20 kilohertz of switching operations, very fast. So here we are going to use the power semiconductor devices. So the power semiconductor devices which are already familiar in our earlier subjects such as EDC and analog electronic circuits, that is AEC. So we are familiar with, but what is the difference between power electronics and this previously studied AEC devices? So in order to go into detail, let me give the definition of power electronics. So power electronics is a technology that is associated with efficient conversion and control of electrical power. So let's say we'll take a source here, and here we have load. So power electronics is a technology that is associated, that means that's associated in efficient conversion and control. So here we have seen how we are going to control. So conversion also possible, that means AC to DC and DC to AC. So source is given to the power electronic circuit which is given to load here. So how we are going to control? So control means we have to take a feedback system from here, and here we have a control circuit and which is given to PEC, power electronic circuit, like this. Okay, so power electronics is a technology that is associated with efficient conversion and control of electrical energy between source and load by using the power semiconductor devices as switches. So as we know that the switch is going to perform two operations: on operation and off operation, and we will discuss in detail what is the on state, what is the off state switches here. And important thing about here is whatever the source and power electronic circuit and load, so they are all are high power circuits, and here the control circuit is there. So this control circuit is a low power circuit. That means, so low power circuit means it's a low power circuit, that means it's a order of milliwatts to watts. And here we are going to, by using this power, we are going to control some watts to megawatts of power. That means we are using small watts of power to control the megawatts of power by using these power electronic circuits. So this is the advantage of power electronic circuits. Now let's discuss about what is the difference between earlier studied AEC and EDC devices, power semiconductor devices, and these devices, power electronic devices. Okay, so in earlier we have studied our analog electronic circuits, and here we have studied already. Now we are going to study the power electronic devices. So what is the difference between power electronic devices and analog electronic circuits or devices? What's the difference here? So generally the first foremost thing is here the power handling capacity is very less. That means it will carry microamps of current to milliamps of current. Here amps to kiloamps it will carry, and similarly millivolts of voltage to volts, here volts to kilovolts, and power simply we can say milliwatts to watts, watts to kilowatts. So by comparison you can observe here, so this analog electronic circuits is used in control circuits, and power electronic circuits are used in main power circuits here. So it depends upon the current or voltage current capabilities here. So analog electronic circuits are nothing but it is used in control circuits, and these are used in main power circuit. Main power circuit. Yeah, there is a major difference here, and important definition difference between the analog electronic devices or small power devices and higher power devices are here no depletion, that means extra depletion is no extra here, no extra depletion layer is present, that is n minus layer is absent. So here n minus layer is present. So this causes increase in power handling capacity, increase in power handling capacity of devices. So what is the conclusion here? The conclusion here is the power electronic devices are having much more power handling capability. So power electronic devices having much power handling capability than semiconductor conductor. So that is analog electronic circuits. Now we will see the different types of semiconductor devices available to us. So here we have the classification of semiconductor devices are based on two types here. Depends upon the material which you are using here. So silicon and silicon carbide. So in silicon we have diodes. The diodes are can classified into Schottky diodes and epitaxial diodes and double diffused diodes. So most probably for exams point of view, so this is the important one, Schottky diode. You can expect some questions in the Schottky diode. And in transistors, BJT, so BJT NPN and PNP, and similarly in MOSFETs, so very high switching operations here. So N channel MOSFET, and in this one we have conventional and SFET and cool MOSFET and N channel enhancement MOSFET. Similarly IGBT. So IGBT is nothing but a combination of BJT plus MOSFET here. So in this one we have NFT and PT. So low value high speed here, and conventional MOSFETs here. So trench IGBT here. So in this power electronics we are going to cover this part of which is based on silicon here. So in thyristors we have thyristor for phase control, that means rectifiers. So thyristor for fast thyristors means we can use for inverters, so symmetric and asymmetric and reverse conducting we will see it. And GTOs, that is gate turn off thyristors, they in this categorized into symmetrical and asymmetric and reverse conducting, and IGCT and MCT. So most probably we'll go up to this IG is SCR and this GTO. So remaining things are similar in operation but difference in construction here. So next we will see the applications of power semiconductor devices. So the power electronic applications here. So now we will discuss the applications of power electronic devices here. So here one thing should be clear, that if you want to increase the power handling capacity of a power semiconductor devices, automatically the switching frequency of the device will decrease. So what will happen if you want to try to increase the frequency and as well as power means the device may get damaged. So that's the reason why if your power handling capacity increases means the frequency is going to be deteriorates here. So let's see from this graph, and we can observe here in y-axis the power handling capacity is there in volt amperes, and in x-axis we have considered the frequency, switching frequency. So here we have frequency here. The first thing is we can observe here triac. So triac is used in the application is washing machine here. So in washing machine we can use as transfer modules as well as triac here. So one thing we have to observe here is triac is a low power, low frequency device. So low power and low frequency applications. So thyristor power handling capacity is more, and what the drawback is frequency. So as the power increase, frequency decrease. So these are having power handling capacities are more, and this is the future development plan of the powertronic devices. That means they are increasing the power handling capacity is here. So you can find here that if you are going to use in HVDC applications. So HVDC means it is going to be convert AC into DC as well as DC into AC conversions we are going to use here. And so after that G2O is in. So G2O is having good frequency handling capacity as well as good power handling capacity, and the limited range is like this. So it is used in electrical traction system here. Next one we can observe transistor modules. So transistor modules find most of the applications in high power handling and high frequency switching operations here, transistor modules. So in transistor modules we are having IGBT is also having more power handling capacity. An important thing for exams point of view, they may ask a question that so which of the following switches having more switching frequency. So switching frequency means MOSFET here. So MOSFET is used in SMPS, switched mode power supplies, SMPS. Okay, so switched mode power supplies, SMPS, it is used here. So which is having high power high frequency handling capacity and a low power handling capacity of the. Okay, so next we'll move to the switches. So switches are the basic properties of switches here. So properties means there are four modes of a ideal switch. So first one is forward blocking. So remember friends here, so forward means it indicates the biasing. So biasing of the switch. So blocking means it is always voltage capacity. So voltage capacity means it is always occurs in off state. So keep this point in mind. So here important points here is, so blocking means voltage handling capacity, so it will occurs in off state. Next one, conduction means current handling capacity that occurs in on state here. So biasing refers, there are two types of biasing, forward biasing, reverse biasing here. So here forward, reverse indicates the biasing here. So let's guess the first case. So forward blocking mode. So forward blocking modes here we are consider the switch here. So it's initially in off state. So we are going to move it to on state here. Okay, the VF is a voltage across the switch here. So forward voltage drop VF. So you are taking place and you are taking minus here. So anode and cathode. So if you draw the characteristics in the XY plane here, you can observe here. So it will occurs somewhere here, ideal point here is somewhere ideal, and practically somewhere here. So ideal is 0 here in y axis, sorry, x axis here, and here we have y axis. So ideally speaking, the voltage drop should be VF should be equal to 0 here. This is the point. If you observe friends, so if you do the characteristics here, so it will be like this. That means all the switches are passive elements here. Passive elements. So next here, forward conduction mode. So forward conduction mode is current is maximum, voltage is minimum here. So that you can observe in the axis here. And reverse blocking mode. So reverse blocking mode means reverse biasing blocking mode. So reverse biasing means reverse voltage off state here. So when you are giving minus and plus supply here, the switch is in off state. So this characteristics resembles here. Okay, and the reverse conduction mode. So reverse conduction mode is possible when the current flowing from plus to minus like this. So reverse conduction is possible. So all the four properties are satisfied by only one device called triac. So that's why it's called as AC switch. So all the four properties satisfied by triac only. So in this, as we discussed earlier, the triac supports all four modes of operation. So forward blocking, forward conduction, reverse blocking, reverse conduction. That's why it's called as AC switch. The example for this one is the fan regulator which we are going in using in our home appliances. And second one here is the SCR. So SCR, that is silicon control rectifier, is a very important part of an powertronic circuits which is act in forward blocking mode, forward conduction mode and reverse blocking mode. So reverse conduction is absent in case of SCR. There is a drawback of SCR here. And so here you can observe the VOL is a load voltage. So load voltage nothing but, suppose here we have a converter, the supply is given. Okay, here we have a load. The load voltage is nothing but VOL here. So when the switches are off state, the switches in forward blocking state, so current is 0. So VOL is equal to I into R, for example, say. So I is 0, V naught is 0 here. That is why VOL is 0 here. And conduction means current starts flowing like this. It slowly increases up to this point. So reverse blocking means again current is 0 like this. Okay, so next we will see the different converters which we are going to study in our further lectures. So first, diode rectifier. So input is AC. So AC is the input here, and fixed DC diode rectifiers. So applications are electrical traction, the relief systems, battery charging. So now we are using the battery chargers. That is a diode rectifiers. In olden days we are using this battery chargers, but now we are replacing with the DC to DC converters and extrapolating and welding and UPS applications here. Next one, AC to DC converter is also known as rectifiers, but the here thing is we can convert the AC to DC as well as DC to AC. So that's why we name it as a converter, not a rectifier here. So phase control rectifier means with the help of firing angle alpha we can control the phase of the system. And the line are naturally commutated AC to DC converters. So because they are line voltage per commutation. So we'll discuss in detail about the commutation techniques. And here remember that in AC to DC converters we are going line or naturally commutation here. Applications are DC drives, electrical traction and synchronous machines. Next, DC to DC converters, nothing but choppers here. It is also known as DC choppers, are also known as DC transformer. Okay, so forced commutation, line load combination we are going to use it. So forced means we are going to force the switching off operation in SCRs here. So here naturally the SCR will off because of its nature of supply, AC supply. And here we are going to switch off the choppers forcefully here. So that's why we are using forced commutation here. So they may classify it as per the commutation and power flow and DC drives and subway cars, trolleys. Next one, DC to AC converters. So fixed DC to variable AC is nothing but inverters. So here we can use line or load or forced commutation. So it depends upon the operation circuits here. The applications are industrial and synchronous motors, industry induction heating. So why? Because here we get a variable voltage and variable frequency here. That's the reason why it is used in induction heating, UPS and HVDC transmission lines through converter DC power into AC power. And last one is AC to AC converters. So fixed AC to variable AC here. So AC voltage controllers is nothing but major application of triac. So next is AC voltage controllers. Here we're going to use triac and cycloconverters. Cycloconverters are nothing but slow speeds large AC drives. That means it will have large mechanical inertia of rotor. Mechanical inertia of rotor machines. That means large machines we can use here. And for lighting and speed control purpose we are using AC voltage controllers. So thank you friends. Thanks for watching. If you like my videos, please subscribe and share with your friends and like. Thank you. Have a nice day.